Here's another trigonometry problem using SOHCAHTOA or Pythagoras' theorem. Here we have an example where we have a triangle ABC, and that's a right angle triangle because of this symbol here. They also have a line A to D drawn in that cuts through the center of this triangle, okay, or through the triangle. We're given that AB is 12, so the distance from A to B is 12. Look, A to B is 12, okay, it's in the picture. We're also told that the size of angle ABC is 40 degrees. So look, A, B, C is 40 degrees. So the middle letter is B there, that's where the corner. Look, A to B to C, so it's 40 degrees. And we're also told that the distance from B to D is 3 meters. B to D is 3 meters. Oh yeah, that distance there is 3 meters. Okay, so part one, they want us to write out angle BAC. Well, let's find BAC. BAC. So they want us to write down the size of this angle here. And then they want us to find the length from B to C. So B to C is B to C. So they want the full length of this guy here, B to C. And then the last thing it says is hence find D to C. So D to C is just this distance here. And usually hence means you're using something you've already discovered to help you. Hence means therefore. Okay, how do you deal with a problem like this? The first step is, if you're not sure what to do, is to draw the triangles out separately. So especially right angle triangles. So I'm going to draw the big right angle triangle on its own, a little sketch. Just a sketch. I'm drawing it a bit smaller here just so I can fit it in. So you got A, B, C. I know this is 12 meters. I know this is a right angle, and I know this is 40 degrees. I don't know anything else about that one. I also have the smaller right angle triangle here, like this, where this is D, this is C, and this is A, and this is a right angle. And I actually don't know anything about that one yet. Okay, now go back to the question and see what they were asking. The first thing we need to do is find out the size of angle BAC. So look, BA to C would be this angle up here. I'm going to colour it in. Now, is that angle on any of our pictures down here? BAC, well, no, that's DAC, BAC, there it is. This angle here. So we're being asked to find this angle. Instead of calling it BAC, I'm going to call it theta. Now, looking at this picture, could we write down what theta is? Well, we can't use SOHCAHTOA because we only know one side. But what we're allowed to use is the fact that the three angles in a triangle always add up to what? What do the three angles in a triangle always add up to? They always add up to 180 degrees in total. So what we can do is, we know this is 90. We can say 90 plus 40 degrees plus our mystery theta. They must add up to 180 degrees. Now, some of you might be more comfortable just adding these guys and then taking it away. That's fine. So I'm going to do that here. 90 plus 40 is 130. Add theta is 180. So theta is going to be 180, take away 130. So theta turns out to be 50 degrees. So theta was an invention of mine. My answer is angle BAC. Angle BAC is 50 degrees. Now, that's my first answer. Whenever you've got new information, you should update your picture. So we now know that this is 50 degrees here. We also know that this whole angle here is 50 degrees, the whole angle. Okay, cool. Now, the next thing is we have to find the distance from B to C. B to C. Now, look, there's no B to C in this picture. There is a B to C in this picture. If I highlight it here, B to C is this distance here. Let's call it X. We want to figure out that distance there. Now, the thing is, we can use SOHCAHTOA here. We cannot use Pythagoras' theorem. The reason we can't use Pythagoras' theorem is we only know the length of one side. Remember, for Pythagoras' theorem to work, we need to know at least two sides, or we need to know two sides. So we can label our triangle. And it's up to you, because we know both angles, it depends which angle you want to use. If I use the 40 degrees, which is what I'm going to do in this example, I'm going to use 40 degrees. So here's my hypotenuse. So this would be H. Because I'm using 40, this would be O, and the X would be A. And then I say, okay, I want to know my x, which is a, and I know h. So which one has a and h in it? Well, it's cosine. So I'm going to write cosine 40 degrees is a over h, which in this example is x over 12. So I've cos 40 is x over 12. I want to get x on its own. To get rid of a divide by 12, I cross multiply. So I can just write that out now and get that on my calculator. So make sure your calculator is on degree mode. You got 12 cos 40, press equals, and I'm getting 9.1925 meters. Now, let's go, if the question tells you the amount of decimals they want, you do what it asks. In this particular case, they didn't give me any decimal points. So I'm going to go to one decimal place. So I'm going to say, actually I'm going to go 2 decimal places. I'm going to say that the distance x, which is B to C, it's called B to C, is 9.19 meters. So there's my answer for part 2. I've just worked out B to C. Now, the last part of the question is they want us to find out D to C. But before I do that, I'm going to update my picture. I now know that 9.19 is the distance from B to C. So if I was to mark that in, the distance from here to here is 9.19 meters. Please note that the distance from here to here is 3 meters. And we want to know this distance from here to here. Can you use the clues here to work out the distance from D to C? Remember, from here to here is 9.19, and from here to here is 3. So what will this distance be? Well, we just take the 3 meters away from the 9.19. So the answer at the end requires no trigonometry. We're going to have 9.19 subtract 3, and that's 6.19 meters. So D to C is 6.19 meters. Notice we didn't actually have to use this triangle in the end.